Hey everybody! As you know, the unit we have been studying is about genetics. And this video highlights the main ideas of probability and Punnett squares. So here it goes. Ladies and gentlemen, this is probability and Punnett squares in plain English. So ask yourself, what the heck is probability? And what in the name of science is Punnett squares? Well, here's the answer. Probability is the likelihood that a particular event will occur. Yeah, well, so what? FYI, probability has many real-life applications. For example, you can use probability while playing a card game. Let's calculate the probability of drawing a heart out of a deck of cards. So what do we already know? We know that there are 52 cards in one deck and there are 4 suits, which means there's 13 cards per suit. That means out of the 52 cards in the deck, there are 13 cards that I can draw that could be a heart. Let's reduce 13 out of 52 to 1/4. Therefore, we can conclude that there is a 25% chance that if I draw a card from a full deck, it'll be a heart. Many poker players use probability when they're playing a high-stakes game. This can make the difference between leaving empty-handed or leaving a big winner. But wait a second. What does probability have to do with genetics? Well, the principles of probability can be used to predict the outcomes of genetic crosses. Now, I know what you're thinking. Miss P, how do I predict these outcomes? Well, you can thank this guy for creating a method for us to get that accomplished. His name is Reginald Punnett, and he's the creator of the Punnett square. A Punnett square is used to compare the genetic variations that will result from a genetic cross. This is what a Punnett square looks like. It's actually a big square divided into 4 small squares. The parents' genotypes are represented at the top and the left sides of the outside of the square, and the alleles of their genotypes are independently inherited by their offspring. For example, let's say we are crossing pea plants, just like Mendel did. We're looking at pea plant petal color. Purple pea plant petal color is dominant, whereas white pea plant petal color is recessive. Purple can be represented by the homozygous dominant genotype and the heterozygous, while recessive can be represented by the homozygous recessive. So let's cross 2 purple plants, one homozygous dominant and one heterozygous. What's the probability of those parents producing a white-petaled pea plant? Let's look at the cross. The probability is 0 because the offspring will need to receive a recessive little b allele from both parents, and in this case they only receive a little b from one parent. But if we cross 2 heterozygotes, can we get a white-petaled offspring? The answer is yes. The probability of producing a white-petaled offspring is 1 out of 4, or 25%.